We are discussing the IIT-JAM 2015 modern physics problems. A particle with energy E is incident on a potential given by Vx is equals to the wave function of a particle for E greater than V0 in the region x greater than 0 is. So we have a barrier at x is equals to 0. We have to determine that is region 1. Second, wave function of a particle in E less than V0 in region second. Solution. In region second is psi is equals to E psi implies minus h square by twice m d square psi by d x square plus v psi equals to E psi. So del square psi by del x square would be twice m h cross square E minus v of psi equals to 0. This can further be written as del square psi by del x square minus twice m h cross square v minus E of psi is equals to 0, or del square psi by del x square minus beta square psi is equals to 0, where beta square is defined as twice m h cross square E minus v. The solution of this equation is above equation is given by psi is equals to a e की power beta x plus d e की power minus beta x. E less than v. Okay. Now we have to check it limiting case. As x tends to infinity, psi x must be 0 implies a must be 0. So the wave function in region x greater than 0 would be d e की power minus beta x. So let us check the option. That means option B is our correct answer. A proton from outer space is moving towards Earth with velocity 0.99 c as measured in Earth frame. A spaceship traveling parallel to the proton measures proton velocity to be 0.97 c. The approximate value of the spaceship in the Earth frame is. Solution. The velocity of proton in Earth frame is Vp is equals to 0.99 c. Velocity of proton as measured by spaceship is Vp dash equals to 0.97 c. According to addition of velocity, the velocity of proton in Earth frame is Vp is equals to Vp dash plus V 1 plus Vp dash V by C square. This can be written as 0.99 C plus equals to 0.97 C plus V divided by 1 plus 0.97 V by C implies 0.9 C plus 0.99 into 0.97 V is equals to 0.97 C plus V, which gives out V is equals to 0.02 divided by 0.0397 into C, that means 0.503 C or 0.5 C. So our answer would be 0.5 C. A nucleus has a size of the order 10 to the power minus 15 meter. Consider an electron bound within a nucleus. The estimated energy of this electron is of the order. Solution. The uncertainty in the momentum of the electron is del P is equals to H cross del X equals to 1.05 into 10 to the power minus 34 divided by 10 to the power minus 15 equals to 1.05 into 10 to the power 19 kilogram meter per second. The energy of electron bound within the nucleus is E is equals to delta P square by twice M equals to 1.05 into 10 to the power minus 19 square divided by 2 into 9.1 into 10 to the power minus 31 into 1.6 into 10 to the power minus 19 is equals to 3.7 into 10 to the power 4 MeV. So our answer for this question is option C. The variation of binding energy per nucleon with respect to the mass number of nuclei is shown in the figure. Consider the following reaction. Uranium decay into 92 into lead plus 10 proton plus 22 neutron, and further uranium decay into lead 206 plus 8 alpha particle plus 6 electron. Which of the following statement is true for the given decay? Both 1 and 2 are allowed, both 1 and 2 are forbidden, 1 is forbidden, second is allowed, or D is allowed, first is allowed or second is forbidden. Solution. The element heavier than lead Pb206 are unstable which attain stability through emission of alpha particle. The uranium 4n plus 2 series terminates at lead PB206 by emitting eight alpha particle and 6 beta particle. Thus, first reaction is forbidden and second reaction is allowed. That means option C is correct. A particle is moving in a two-dimensional potential well. Vxy is equals to 0xl and 0y 2l 0. Which of the following statement about the ground state energy E1 and ground state function phi 0 are true? Solution. The energy eigen values for a particle confined in two-dimensional well potential well is En is equals to pi square h square by 2m to nx square by a square plus ny square by b square, and its corresponding eigenfunction is psi xy equals to 4ab sin nx pi x by a sin ny pi y by b. The ground state energy of the particle is E11 is pi square h square by twice m into 1 by l square plus 1 by 2l square equals to 5 pi square h square by 8 ml square, and the ground state wave function is psi 11 is root 4 L into 2L sin pi x by L sin pi y by 2L is equals to root 2 by L sin pi x by L sin pi y by 2L. Here Lx A is equals to L and B is equals to 2L. Thus, option C and option B is correct. Muons are elementary particles produced in the upper atmosphere. They have a lifetime of 2.2 microseconds. Consider muons which are traveling vertically towards the Earth's surface at a speed of 0.998 c. For an observer on Earth, the height of the atmosphere above the surface of the Earth is 10.4 km. Which of the following statements are true? Solution. We have tau 0 is equals to 2.2 microsecond, V is equals to 0.998 C, L is equals to 10.4 kilometer, and C is equals to 3 into 10 to the power 8 meter per second. The apparent thickness of Earth's atmosphere in muon's frame reference is L naught is equals to CT naught 3 into 10 to the power 8 into 2.2 into 10 to the power minus 6 is equals to 0.66 kilometer. The lifetime of muons in Earth's frame of reference is T is equals to T naught 1 minus V square by C square, that is 2.2 microsecond divided by 1 minus 0.998 square equals to 34.8 microsecond. Let the velocity of muon is equals to 0.99 c. The lifetime of muon in Earth's reference frame is T is equals to T naught 1 minus V square by C square is equals to 2.2 microsecond 1 minus 0.999 square equals to 49.2 microsecond. The distance traveled by the muon in Earth frame is L is equals to C tau 3 into 10 to the power 8 into 49.2 into 10 to the power minus 8 equals to 14.76 kilometer. The distance is greater for minus 6. The distance is greater than the height of atmosphere above the earth. Where they were first noticed by the observer. Hence, they reached the earth. Now check out the option. First, The muon can never reach the statement. We cannot say it. The apparent thickness of Earth atmosphere in muon frame of reference is, according to us, 0.66 kilometer. 0.66 kilometer. Third, the lifetime of muon in Earth frame of reference is 3.48 millimeter. बिल्कुल सही है. ठीक है, ऑप्शन सी इज करेक्ट. Muon traveling at a speed greater than 0.998 reach the Earth surface. Here you can check it. We have taken the velocity 0.99 c, and in that case this distance is 14.76 kilometer. So this is greater than the height of the atmosphere above the Earth surface. ठीक है, where they were first noticed by the observer. Hence they reach the distance. That means our options C and D are correct. Is correct answer. A particle is in a state which is superposition of ground state phi 0 and first excited state phi 1 of a one-dimension quantum harmonic oscillator. The state is given by phi is equals to 1 by root 5, 2 by root 5. The expectation value of energy of the particle in the state in unit of is. So, solution phi is given by 1 by root 5 root phi 0 plus 2 by root 5 phi 1. ठीक है. So where phi of phi is normalized, further probability of finding the particle in state phi 0 is 1 by 5. Having energy E0 is equals to 1 by 2 h cross omega. Similarly, probability of finding the particle in state phi 1 is 4 by 5, and having energy is equals to 3 by 2 h cross omega. The expectation value of energy is given by is equals to summation Pi Ei, which is equals to 1 by 5 into 1 by 2 h cross omega plus 4 by 5 into 3 by 2 h cross omega. That is 13 by 10 h cross omega, 1.3 h cross omega. So answer is 1.3. In the hydrogen atom spectrum, the ratio of longest wavelength of Lyman series to that in the Balmer series, final state N1 to that of Balmer series N2 is. Solution: the wavelength of transition according to Bohr's theory atom is 1 by lambda r infinity 1 by n f square minus 1 by ni square. The maximum wavelength in the Lyman series corresponds to n is equals to 2 to 2, n1 is equals to 1, or nf is equals to 2 to ni is equals to 1. That is 1 by lambda max L is equals to R into 1 by Ni is equals to 2, Nf is equals to 1, 1 by 2 square equals to 3 by 4 R. Similarly, the maximum wavelength in Balmer series corresponds to NF is equals. Sorry, here I would be making one correction. NF is equals to 2 and N initial is equals to 3. Here you should change it. Make correction to the formula. In general, it would be N1 square minus N2 square. For Lyman series, N1 will be 1 and next term N2 would be 2. For Balmer series, N1 is equals to 2 and next term would be N2 would be 3. So we just making it in terms of N1 and N2. So for Balmer, N1 would be 2 and N2 would be 3. So 1 by lambda max B will be R into 1 by 2 square minus 1 by 3 square would be R into 1 by 4 minus 1 by 9, that is 5R by 36. Thus, the ratio of lambda max L to lambda max B is 1 by lambda max L B is divided by 1 by lambda max L equals to lambda max L by lambda max B is equals to 5 R by 36 divided by 3R by 4 equals to 5 by 27 equals to 0.1852. Thus, our answer is 0.1852. A rod is moving with a speed 0.8c in direction at 60 degree to its sound length. The percentage contraction in the length of the rod is. We have V is equals to 0.8c, theta equals to 60 degree. If the rod is aligned at an angle in the moving frame, then the x component of velocity is responsible for the length contraction in the rest frame of the observer. That is L dash is equals to L naught 1 minus Vx square by c square is equals to 1 minus V square by c square cos square theta, which is equals to L naught 1 minus 0.8 by 2 square, which is equals to 0.91 into L0. percentage change in length is lot minus L divided by L naught into 100 is to 1 minus 0.91 L0 divided by L0 into 100 to 0.09 into 100 equals to 9%. That is 9%. X-rays of wavelength 0.24 nanometer are Compton scattered, and the scattered beam is observed at an angle 60 degrees relative to the incident beam. The Compton wavelength of the electron is 0.00243 nanometer. The kinetic energy of scattered electron in electron volt is. Solution. We have lambda is equals to 0.24 nanometer. Lambda is equals to 0.00243 nanometer and theta is equals to 60 degree. The wavelength of scattered electron is lambda dash is equals to lambda plus lambda c 1 minus cos theta is equals to 0.24 plus 0.00243 1 minus 1 by 2 equals to 0.2412 nanometer. The kinetic energy scattered electron is hc by lambda minus hc by lambda dash is equals to 6.6 into 10 to the power minus 34 into 10 to 10 to the power 8 divided by 1.6 into 10 to the power minus 28 1.024 minus 0.2412 EV, which is coming out to be 12.375 into 10 to the power into 10 to the power 2 into 4.17 in minus 4.15 EV, which is equals to 4.75 EV. So our answer for this problem is 2475.